The Gauss rifle uses predominantly mechanical concepts in order to create a magnetic chain reaction. By starting with a single stationary metal ball, the Gauss rifle can use another ball to reach a very high speed within seconds, which then exits the rifle as a projectile. One of the most crucial concepts of this project is magnetic fields and forces. The magnetic fields are generated from the 4 permanent magnets within the system. These fields create magnetic forces that propel the magnetic balls forward. The metal balls are ferromagnetic, so while standing alone they are not permanent magnets. They can act as a permanent magnet in the presence of an external magnet. Consider each metal ball as made up of many small domains. A ferromagnetic material standing alone with no external magnetic field will consist of domains, each with a magnetic field pointing in arbitrary directions. However, when the ferromagnetic material, in this case the metal ball, is placed in a magnetic field, which in this case is generated by the permanent magnet, all the magnetic fields of the domains will realign to face the direction of the external magnetic field. In this case, the external magnetic field is B0 and it's in this direction, so all the internal domain magnetic fields realign into that direction. This creates a magnetic force, which is how the metal ball is attracted to the magnets. This brings us to our next crucial concept. Newton's first law of motion, also known as the first law of inertia, states that an object at rest tends to stay at rest, and an object at motion tends to stay at motion with the same speed and in the same direction, unless acted upon by an unbalanced force. Because of the magnetic force acting on the steel balls are coming from the external unbalanced force, if the steel ball is already moving at some constant velocity, it will accelerate and change velocity.
Following the laws of conservation, both total energy and momentum must be conserved. Although total energy is conserved, kinetic energy is clearly not, because as the steel balls move across the track, velocity will increase. Magnetic potential is a result of the internal structure of the material. Therefore, while it cannot be seen, such as in gravitational potential energy, the magnetic potential energy does decrease, therefore conserving total energy. Although the kinetic energy is not conserved, meaning the collision is inelastic, the momentum should be conserved. Looking at the equations P equals mv and P initial equals P final, the masses can cancel out since all the balls have the same mass. Therefore, V initial equals V1 final plus V2 final. V2 final clearly increases since the ball that continues forward does so with a higher velocity. However, look at the initial ball after it hits the magnet. It recoils, therefore having a negative velocity. Therefore, V initial equals V2 final minus V1 final, and momentum is conserved throughout the entire system. One final thing to mention is the number of balls and why there are 3 steel balls between each 2 magnets. It has been determined in past experiments that using either 2 or 3 steel balls creates the optimal condition. The reason for this would be because while the first and second ball, the ones closest to the magnet, will remain stuck to the magnet due to the magnitude of the magnetic force acting on them, the third one will receive all the transfer of the kinetic energy and will be the one moving forward. In a sense, the first 2 balls act as a buffer between the magnet and the third ball so that the third one can continue moving forward. Ported the video into tracker and then frame by frame tracked 5 points of mass, one for each segment of the rifle. Looking at the graph of acceleration versus time, we found the curve of best fit for each segment in order to approximate the acceleration of the ball over time. Looking at the velocity versus time graph of the first and last mass points, we see that the velocity of the ball exiting the rifle is higher than the velocity of the ball entering the rifle. This therefore shows that the Gauss rifle does increase the velocity over time. In this video, we have built only a crude demonstration of the power of magnetic projectile acceleration. However, with a good number of sufficiently strong magnets, even fully automatic machine guns and non-rocket space launchers can be built.